In today's video, I would like to show you how we can utilize Autodesk's 1-to-3D Catch, a photographic approach to digitizing 3D objects. Photographic approaches are very easy and fast. The downside is precision compared to a laser digitizer. However, a really good laser digitizer starts at few $1,000s, and Autodesk 1-to-3D Catch is actually free. So, and because we only want to roughly digitize our foam models to bring them into our CAD environment, it's not really a big problem. So, for example, what you see here is a quick digitizer of my Bosch power tool. So you see it in many areas. It captured the details quite nicely, and some areas not necessarily. You can see those parts here, the button for left and right. If I go into the plane shaded mode, you can see the different geometry structures, even here kind of like the grooves for the front part. So it's not super precise, but again, this is actually a pretty decent representation of the hand drill I have, and I could sufficiently utilize this as a three-dimensional blueprint, because even when you do sketches and you put them into your CAD application to draw over, your sketches aren't super precise. But this can be really great to help you to get proportions, etc., transferred quickly into a 3D environment and then rebuild this design with the native application tools. Also, as you notice, the nice added benefit of 1-to-3D Catch, because it's photographic, it also comes with the textures. So let me show you how we have to start. First, please go to the course website, go to software, scroll down, go to Autodesk Educational Community, go to register, follow this form, and basically you create an account as a student. So for example, student, and then this way you will get free access to all the Autodesk educational software, which for example for next semester includes Alias, and also for this semester will include Fusion 360. And once you're done, you can go to 1-to-3D Catch or to the 1-to-3dapp.com website of Autodesk. So 1-to-3dapp.com. And that's Autodesk's, I would say, maker website. They offer a nice set of interesting 3D tools to just play around with 3D. And the one of interest for us, of course, is 1-to-3D Catch. You can download the software for PC. There is no version for OS X, so for the Mac. However, if you have an iPad, you can also download the app right onto your iPad. Unfortunately, there is no app for Android. However, because I like to work mobile and have access to my data and the tools wherever I am, I'm going to use the web interface. So I click on Launch 1-to-3D Catch Online. Let's close this for a moment. So for example, here you can sign in with your just created account. Will take a second. And then you can go to New. And you will be presented with this interface. Create a new capture, select photo or drag and drop. You have 70 photos. Capture resolution is low right now. So let me show you actually how this works. So this is actually a pretty simple process. So I have, for example, my recharger bottom. Yeah. So let's go to quick view. So what you have to do is you can use any camera or even your smartphone. All these photos here are done with my smartphone. You have to do like series of photos where every time you walk around your object in small steps and then snap a photo. The smaller you can make the steps, so for example, you see from here to here, I moved to the side a little bit, but from here to here or from here to there, I moved quite a lot. So the smaller you can make the steps, the better it will be. Just to get this done quicker, I just accelerated this a little bit. So you see like you go 360 degrees around an object. And for example, here is the last image of the series. And then starting with this image, I moved the camera up a little bit and then walked around the object again. And then here I restarted looking even further down onto the object and walked around and digitized it. The way how the software works, and that's the reason why I also said try to make really small and nice steps, is by comparing the different photos. And based on what changed, it can analyze where actually there is a geometry to digitize, and then it will create a polygon cloud, which then will be created into a surface, like what I showed you with the power drill. Few tips. Try to shoot your object onto some sort of textured ground. So for example, here you see I have a wood floor. That's very great because in each image you see the wood floor rotates. This really helps the software to understand the differences between the different images. Try to have a nice and uniform light. So for example, what is bad in this image is all the light comes from the window, so this is clearly in a really dark shadow area. The software can really see, and even the photo for your eye, it's difficult to see the different details. For example, here it's a little bit easier because of the highlights to see all the different geometry details. So you should have a nice illuminated environment. You can have a drop shadow or something like this, but try to prevent having like really dark areas. Also, like here, try not to stand in front of a light, because then you can cast a shadow onto the object, and that will confuse the software as well. This object currently is white, and my scan actually worked somewhat okay, but if you want to also furthermore help the software, because you're going to digitize a full model, let me go to Google. Let's type in product sketching images, and for example here, you can try maybe drawing those lines, those curvature lines onto your object, because this actually will help the software to understand and read the shape a little bit better. And for example here, if this center line wouldn't be there, you wouldn't necessarily know if this object is bent to the left or if it's actually just bent backwards. And then when we have other horizontal lines in addition, it really helps the software to understand, like this actually helps your eyes to really read the proportion and how the surface is or should be created or will be created, because this is a 2D image. A photo is 2D, so the software can't really know what is 3D. So by providing it a lot more help, and then of course your lights, your highlight and your shadow will furthermore, for example, help the software to understand what to do and how to interpret the different images. So, and yeah, I have 30 images. You can have maximum 70. So probably with a double amount of photos, my scan result would probably even be a notch better. So let's go back to 123D Catch. So everything you do is once you have this create new capture, select all the photos, drag them into this field, and then you see it will show all the different thumbnails. Set your resolution to high, and then basically click on process. Don't close the window because it's first the software has to upload all the images. This also means try not to shoot images kind of like with 1 megabit. If you have like a 5 or 8 megabit camera, just shoot it with high res, so full amount of pixels. The more information you give the software, the better the results afterwards will be. So while the one is actually working, let's go to a different window and let's go open. And the software doesn't like me today. So let's restart it. Open. There. So there you see, for example, currently it is processing my capture. So this means uploading the images and then generating the 3D data. You see actually here, I did various tests and with small variations. And again, here, for example, you see I did captures on a white sheet, worked okay, but sometimes the problem is if my object is white and the background is white, the scan can result in pieces blending together, and then when I draw something onto a white sheet, I can separate my background actually from my subject matter or my object. And that will then help the software to understand what is a flat plane and where is actually an object to digitize. Also very important, for example, compared between those two, try to get really close, not too close, so you're still in focus, but try not to take a photo of your object really far away. Try to zoom in as much as possible so the software gets a decent amount of pixel information of your object. So once this one is uploading, let's open this one. So then you see the interface is working, it's validating the model, opening the model, and then with the right mouse button, you can rotate, middle mouse button, you can pan, and with the scroll wheel, you can zoom in and out. And there you can see, for example, small details it lacked. Okay, so there are some repair tools inside the web interface. For this, you would have to download the Catch plugin, but I'm actually skipping this part because all the stuff we're going to do inside the Blender interface. So you could go to OBJ. You can also export as STL. Currently, because it is all in test, we can export as OBJ. So you will get a warning that it's for premium membership, but at the moment we can still export the OBJ file for free. When you click OK, it's processing and then it's downloading a zip file, because the whole point behind the OBJ is it actually comes with the texture files. So for example, here's a folder of my charger from the bottom and top, and each one has its own texture. And then those mesh.obj, those are the mesh models. And those two we have to bring into Blender and then scale them, stitch them together. So let me show you this right now. So because I work here in my studio in metric, I'm setting Blender to metric. Let me turn on my screen keys. Then you could go to File, Import, Wavefront, and maybe I start with the bottom one. So once I click Import OBJ, the software is working. Takes a second because it's a pretty big computer model to load. And there is now the lower part digitized. Small problem you can see, and that's also why I mentioned try to have nice and even light. You can clearly see this part inside the computer model. This actually faced the sunlight. On the other side, you can see it's very blobby. So that was actually in the shadow area. So that one is actually less usable. So again, that's the reason why to try to make the photo shooting in nice and uniform lights. You can have some shadows, but again, don't keep things in the shadow. Okay, so maybe we can rotate this object a little bit, and then we can select it, press tab, go into edit mode, and then with B and middle mouse button I try to draw a selection over my object. So this way I deselect what is selected, press X, and delete all the vertices I really don't need. And maybe here from a side I select this part, and let me turn on the texture, because I have to trim everything a little bit right now. So you see kind of like everything that's black, that's more or less what I can cut away. So I can zoom in a little bit, and then I see the result or the texture a little bit better. Also, as you can see, currently I work in the Blender render mode, so I don't have cycles turned on right now. This way I can quickly, without too much extra work, have this, the texture of my scan shown when I have the viewport to texture. And then I just continue trying to select most of the mesh that is kind of like darkish. Okay, and then I press X. Vertices, or no, actually I say faces this time. And let's see how this one turned out. Hold on. No, actually I do vertices. The reason with faces and vertices, all the points I selected, when they're connected to your face, that face is then being removed as well. Okay, so now we have to figure out actually the scale. So I'm using my ruler and see where maybe I have on this object some scan information I can use. So for example, I know that this part here, this distance, seems to be 5.75 centimeters. So I could create, for example, a cube. and then say x 5.75 centimeters, maybe 2 centimeters, 2 centimeters. So I have to scale my model down so that this part here will fit into that cube. So I'm going to maybe move it back. And I have to scale it down a lot. And move it to there. Maybe like this. And then I try maybe to put my 3D cursor to there. And then set cursor for the pivot point. Select my object. Press S. Because now I can scale the other side to the 3D cursor. And then when this edge touches the other part of my reference cube, I roughly know that this scan is now maybe scaled to the correct dimension. And also this part actually I can use to maybe see if I have to do some further rotation. And you can actually see that there is a slight offset. So maybe just 0.2 degrees. Let's see. Now, yeah, this works pretty well. So that's actually the nice part about the OBJ one, because you do not only get the scan data, you get it with the textures, and the textures can be really, really helpful for identifying, for example, rotation or scale. And what I measured this part here on my actual piece, if you have a flat surface of your mesh, you can also write down or mark, for example, the distance of 1 inch, and then if it's a flat surface, use that as a reference for the scaling. So this is basically part 1. Now we have to bring over part 2. So for example, the top. And the mesh top one was actually difficult for the software to figure out. One side, the lighting wasn't really the greatest. And also this is a black material, and it is also reflective. But it was able to capture quite a lot inside, but you see it is kind of rough. So small tip actually when you have to digitize something like this. For white surfaces, I mentioned to help, or like a foam model, nice lighting, so no harsh what's bright and harsh shadows, even lighting, maybe with some shadows or so on the ground plane or something like that, and maybe cross section or surface curvature profile lines on the foam model. Now for dark areas, because shadows are dark, you can't really see a dark shadow on a dark surface. You can use something like dry shampoo. Like if you get that spray can, it is kind of like works like a starch material. So you could basically coat the plastic with the dry shampoo, and then it's brighter. The shadows will be better to see, kind of like what's in highlight, what is in shadow, the way how the light illuminates the surface will be easier for the software to see, and that will actually generate into a better scan result. So I have to do the same here again. So I go into edit mode and then try to deselect all the stuff I don't really need. Delete it. And then let me see where I can measure something here. So for example, this opening here should be 0.6 centimeters. So I'm just scaling this one down. And this one, for example, I set to 6 centimeters. Maybe like this. And I'm just trying to position my 3D cursor to there. I still have 3D cursor set for the pivot point, and then try to scale it maybe like this. Yeah, that should roughly do it. Okay. Then again, I can maybe use this cube to see if my scan is rotated correctly, and mainly it seems to be okay. Okay, good. Yeah, and then I have to do the same, like a little bit of extra cleanup. So for example, from here, I could be really aggressive and maybe all I want actually from this scan is just the upper surface. So I try to get really close. So I'm using my marking cursor with a big radius. The inside, of course, I have to deselect because I don't want to delete this. Okay. Before I delete this, actually, let's make one last check. Okay. And let's delete everything. This one can be removed. Okay, good. So now what we have to do, and I'm going to shoot myself because, oh no, it's, oh, oof, it's there. I thought like by accident I removed this one, but no, it is actually there. So now I have to line them up. So this part I have to rotate 180 degrees, move it to the front, maybe move it in slightly. Maybe go to there, and again this texture mode is really stunningly helpful to make a good lineup. So because this top scan is very rough, question is how precise, for example, the scans are. And again, you know, as I mentioned, this is all about trying to capture maybe the volume. So I'm just trying to even out the scaling a little bit. And I'm lining up the different parts better. Maybe this part still should have been smaller, like I had it before. Yeah, like this. Okay. So, few things left to fix. So, for example, what do we have here? We have an interesting whatever this is on the inside. This we can remove. And then for this one here, we can do the same. Remove the faces. Now, for example, you see we can see through. Maybe I cut a little bit too much, but that's okay. I didn't really pay a lot of attention to digitize that part. But I hope that you start actually just seeing the process that I'm trying to do. And maybe this one I move over just a notch. Yeah, okay, good. Yeah, so at this step, I think we're maybe close to fuse those parts together. So what I'm going to do is selecting one edge. This is my good scan, this is the bad scan, so this part maybe I'm going to discard. So both objects selected, you can go to join, and then if I go into edit mode, maybe I try to draw before I do this, hold on, very important. I know I need to try to line up my object as closely as possible. So let's say I set my 3D cursor to along the x-axis at 0 and 0 there. Okay. And I use this one, and no, actually I create a new plane. Let me rotate this plane, because now I can use this to see how, for example, how far this object is centered, and then actually now it looks, at least here, somewhat centered. This maybe should be 3 centimeters. Okay. 2.9, 2.8. Okay, so this is close. I could also simply have used the grid, but I like having this mesh, so when I select it, actually I can see like this line right above my object. So now I go to origin, 3D cursor. See, my 3D cursor now is at the Z center part. And I can go into edit mode. Let's see which one is the bad side. So the right side is bad. B, select everything from here. And for example, delete the faces. Now I have half a model. I can add a mirror modifier, which is going to be a problem because this is rotated. Not a big deal. See, there's a rotation. So we select the object, apply rotation, then the mirror function will work better. And maybe we can rotate it by 90 degrees. Touch it up a little bit more. Okay. origin, maybe origin geometry. Oh no, don't do this because of course that's going to be problematic because we need this point to be basically at the center for the mirror function. So I just reset. You saw I moved my object down, so I reset the origin to where my 3D cursor is, because now I'm free to move this one around wherever I want. And my object is basically finished. So at this point, maybe one last check. And you see it fits in. So the cube goes from left side to the right side. The edges are parallel. So basically, I would say this is a somewhat really usable computer model I digitized. They are because, of course, my top model was not really the greatest. You can see that there's a little bit of overlap and issue there. But that has nothing to do with Blender, but it's probably more that the laser scan which I created there is just a little bit garbage. So maybe here, sayonara. I opened it, but again, this is just for getting an idea. Because at this point now, you can actually go ahead and then build a cube, scale the cube down. And for example, yeah, start rebuilding your product by using the digitized surface simply as a reference. So see, like this way I quickly blocked out most of the model. Maybe go a little bit wider there. Yeah, and then from there, step by step, you would start rebuilding or basically building your design, but utilize the scan data kind of like as a volumetric blueprint. Last thing I would like to point out, you can see the textures are actually still there. By using the mirror modifier, of course, the textures are also flipped. So this is attention and attention backwards. If you would like to keep those textures inside your blend file, you have to go to File, External, Pack into Blend File. And then you could go Save as Desktop. For example, recharge or scan. And then when I reopen it, you see the texture is still there. It comes in with the blend file, so you don't lose it. And yeah, so that's basically everything to how to utilize 123 Sketch and those digitized models for creating three-dimensional blueprints, which then you could use for your design process. And again, precision in this point is not really as important because 123 Sketch is not extremely precise. But this whole lecture took me now 39 minutes to record. The MakerBot digitizer, one pass takes 12 minutes, 2 passes. Yeah, so you see, it's not really that much slower. Plus, the nice part is also we have a texture on the object. Plus, because of the nature of 123D being photographic based, you're not limited to any location, because there are people who digitize houses. Of course, they don't capture all the fine details, but or cars. So it really doesn't matter what you try to digitize in terms of scale or where they are positioned. That's a really nice part about it. The downside, of course, is the resolution. But again, we're using this one only for making quick digitized digital foam mockups.